Find an integer m in terms of n such that summation of k varying from 1 to n, 1 divided by k multiplied by k plus 1 multiplied by k plus 2 is equal to 1 by 4 minus 1 by m. We can do the problem in the following way. Let k, so that is 1 divided by k multiplied by k plus 1 multiplied by k plus 2 be a by k plus b by k plus 1 plus c by k plus 2. Remember your partial fraction lessons. And in this, a, b and c are to be determined. Now the right hand side is a by k plus b by k plus 1 plus c by k plus 2. If you do the addition, the denominator becomes k, k plus 1, k plus 2, multiplication of the three terms, and the numerator becomes a multiplied by k plus 1 multiplied by k plus 2 plus b multiplied by k multiplied by k plus 2 plus c multiplied by k multiplied by k plus 1. And that is equal to a, and if you multiply these two terms we get k square plus 3k plus 2. Similarly, when you multiply these two terms we get b multiplied by k square plus 2k, and the last term becomes c divided by k square plus k. And the denominator is the same as before, which is k multiplied by k plus 1 multiplied by k plus 2. And that is equal to, we notice that there is a k square term here, there is a k square term here, there is a k square term here. So we separate out the three k square terms to get k square multiplied by a plus b plus c. Similarly, there is a k term here, there is a k term here, and there is a k term here. So we separate out the three k terms to get k multiplied by 3a plus 2b plus c, and finally there is a constant term 2a, and the denominator continues to remain as before, which is k multiplied by k plus 1 multiplied by k plus 2. Okay, so again, that is left hand side, that is this, is equal to this. Since 1 divided by k multiplied by k plus 1 multiplied by k plus 2 is equal to k square multiplied by a plus b plus c plus k multiplied by 3a plus 2b plus c plus 2a divided by k multiplied by k plus 1 multiplied by k plus 2, we get k square multiplied by a plus b plus c plus k multiplied by 3a plus 2b plus c plus 2a is equal to 1. Why that is so? Because this denominator is same as this denominator, and we can strike them off. Now, from this equation, there is a k square term, there is a k term, and there is a constant term. Now, k is a variable, so we can equate the k square term and the k term and the constant term on both sides of the equation. Since there is no k square term on the right hand side, we conclude that k square multiplied by a plus b plus c is equal to 0. Since k cannot be 0, why k cannot be 0? Because if k becomes 0, this term is become indeterminate, so k cannot be 0. Since k cannot be 0, we get a plus b plus c has to be 0. Similarly, there is no k square term on the right hand side, hence this term also has to be 0. And because k cannot be 0, we therefore get 3a plus 2b plus c is equal to 0. Finally, this is a constant, this is a constant, so this has to be equal to this. So we get 2a is equal to 1. Let us call these three equations as equation 1, equation 2 and equation 3. From equation 3, we directly get a is equal to half. Putting this value of a in equation 1 and 2, we get b plus c is equal to minus half. Let us call it equation 4. And 2b plus c is equal to minus 3 by 2. Let us call it equation 5. Subtracting equation 4 from equation 5, we get b is equal to minus 3 by 2 minus within bracket minus half, that is equal to 3 minus 3 by 2 plus half, and that is equal to minus 1. So b is equal to minus 1. Plugging this value of b into equation 4, we get minus 1 plus c is equal to minus half. Therefore, c is equal to half. So we get a is equal to half, b is equal to minus 1, and c is equal to half. Now putting these values into our original equation after partial fraction, we get 1 divided by 1 multiplied by k plus 1 multiplied by k plus 2 is equal to a by k plus b by k plus 1 plus c by k plus 2, and a being half, the first term becomes 1 by 2k, b being minus 1, second term becomes minus 1 by k plus 1, and c being half, the third term becomes 1 divided by 2 multiplied by k plus 2. Therefore, summation of this will become summation of this, or summation of k varying from 1 to n of 1 divided by k multiplied by k plus 1 multiplied by k plus 2 is summation of k varying from 1 to n within bracket 1 by 2k minus 1 by k plus 1 plus 1 by 2 multiplied by k plus 2. We will now expand the right hand side and write down the terms for k is equal to 1, 2, 3, 4, etc. as shown below. The first term for k is equal to 1 becomes half minus half plus 1 by 6. The second term for k is equal to 2 becomes 1 by 4 minus 1 by 3 plus 1 by 8. The third term for k is equal to 3 becomes 1 by 6 minus 1 by 4 plus 1 by 10. The fourth term for k is equal to 4 becomes 1 by 8 minus 1 by 5 plus 1 by 12. The fifth term for k is equal to 5 becomes 1 by 10 minus 1 by 6 plus 1 by 14. The sixth term for k is equal to 6 becomes 1 by 12 minus 1 by 7 plus 1 by 16. The seventh term for k is equal to 7 becomes 1 by 14 minus 1 by 8 plus 1 by 18. This will continue until then the n minus third term will become, for k is equal to n minus 3, 1 divided by 2 multiplied by n minus 3 minus 1 divided by n minus 2 plus 1 divided by 2 multiplied by n minus 1, and for k is equal to n minus 2, the n minus second term will become 1 divided by 2 multiplied by n minus 2 minus 1 divided by n minus 1 plus 1 divided by 2n, and for k is equal to n minus 1, the n minus first term become 1 divided by 2 multiplied by n minus 1 minus 1 by n plus 1 divided by 2 multiplied by n plus 1. And finally, the last term k is equal to n, or the nth term, becomes 1 divided by 2n minus 1 divided by n plus 1 plus 1 divided by 2 multiplied by n plus 2. Now, note that in the above table, each of the middle negative terms cancels out with two opposite terms at the edges, one before it and one after it, as shown by different colors. The first two terms for k is equal to 1 cancel with each other. Hence, after all the cancellations, we are left with the following highlighted terms, which I will show you now. So here in this table, let me point out again that these two terms cancel out. Now this term 1 by 3 minus 1 by 3 cancels out with 1 by 6, 1 by 6. This term 1 by 4 cancels out with minus 1, 1 by 8 and 1 by 8. This term minus 1 by 5 cancels out with 1 by 10 and 1 by 10. Similarly, minus 1 by 6 cancels out with by 1 by 12 and 1 by 12. Minus 1 by 7 cancels out with 1 by 14 and 1 by 14. So this goes on. We note here that one term here is left out, which is not cancelling with anything, because we have not gone, we are starting the series at k is equal to 1, not before that. And in the seventh term, this minus 1 by 8 will similarly cancel out with 1 by 16 here and 1 by 16, which will be coming later. And this term will also cancel out with minus 1 by 9 and another 1 by 8, which will come later. So these two terms also will cancel out. Finally, this term will cancel out with n by 2 will cancel out with this and this. This term will cancel out with this and this. This term will cancel out with this and this. And this term will remain because the series gets terminated at k is equal to n. And these two terms, which are highlighted, we notice that only half cancellation takes place between these two terms, and together they become 1 divided by 2 multiplied by n plus 1 minus 1 by n plus 1, which is equal to 2 multiplied by n plus 1 will be the denominator. In the numerator, it will be 1 minus 2, which is equal to minus 1 by 2 multiplied by n minus 1. Now, after cancelling out all the terms as we have explained, we will get only 1 by 4 minus 1 divided by 2 multiplied by n plus 1 plus 1 divided by 2 multiplied by n plus 2, and that is equal to the original summation that we desired. Now, if we simplify the right hand side, we get 1 minus 4 minus, we add up these two terms, we get at the denominator 2 multiplied by n plus 1 multiplied by n plus 2, and at the numerator we get n plus 2 minus n plus 1, which is equal to minus 1 by 4 minus 1 divided by 2 multiplied by n plus 1 multiplied by n plus 2. The right hand side is of the form of 1 by 4 and 1 minus 1 by m. Therefore, m is equal to 2 multiplied by n plus 1 multiplied by n plus 2. And that is the answer. While this completes the problem, I would like to show a shorter method using what is known as a telescopic sum. Before going any further, please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later if you want to. More importantly for me, if you like, share and subscribe, it would encourage me to make and post new videos for you to view. Also, if you know about any interesting problems that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. Fraction is 1 divided by k multiplied by k plus 1 multiplied by k plus 2. Now, instead of doing three terms as partial fractions a, b, c, let us do it with two terms, that is only a and b, where a is equal to this and b is equal to this. That means 1 divided by k multiplied by k plus 1 multiplied by k plus 2 is equal to a divided by k multiplied by k plus 1 plus b divided by k plus 1 multiplied by k plus 2. If you do the addition, the denominator becomes k, k plus 1, k plus 2 as it is here, and the numerator becomes k plus 2 plus k plus 2 multiplied by a plus kb. Hence, since the two denominators are the same and k is not 0, we can cancel them out. Therefore, we get k plus 2 multiplied by a plus kb, which is on the right hand side, is equal to 1, which is on the left hand side. Or k, that is k term is occurring here, k term is occurring here. If you collect the k terms together, we get k multiplied by a plus b plus 2a is equal to 1. Equating k term on both sides, we get k multiplied by a plus b is equal to 0. Hence, since k cannot be 0, a plus b is equal to 0. And equating constant terms, we get 2a is equal to 1. Therefore, a is equal to half and b is equal to minus half. Now putting these values in this equation, we get 1 divided by k multiplied by k plus 1 multiplied by k plus 2 is equal to 1 divided by 2k multiplied by k plus 1 minus 1 divided by 2 multiplied by k plus 1 multiplied by k plus 2. This minus sign is occurring because the value of b is equal to minus half. Okay. Now we can sum both the sides while k varies from 1 to n. That is, this summation is equal to summation of this term. When k assumes different values, we get the following terms. First term is equal to 1 by 4 minus 1 by 12 for k is equal to 1. Second term is equal to 1 by 12 minus 1 by 24 for k is equal to 2. Third term is equal to 1 by 24 minus 1 by 40 for k is equal to 3. Fourth term is equal to 1 by 40 minus 1 by 10 for k is equal to 4. And the nth term is 1 divided by 2n multiplied by n plus 1 minus 1 divided by 2 multiplied by n plus 1 multiplied by n plus 2 for k is equal to n. We see here that when you add these terms up, 1 by 12 will cancel with minus 1 by 12, 1 by 24 will cancel with minus 1 by 24, 1 by 40 will cancel with minus 1 by 40. Similarly, this will cancel with what will occur later. This will cancel with the previous term, and only thing that will be left out will be the first term and the last term. When all the terms are added, all the middle terms cancel out as we have seen, leaving behind only the first and the last terms. Therefore, summation of k is equal to 1 to n of 1 divided by k multiplied by k plus 1 multiplied by k plus 2 is equal to summation of uh, k varying from 1 to n, 1 divided by 2k multiplied by k plus 1 minus 1 divided by 2k plus 1 multiplied by k plus 2, and that is equal to 1 by 4 minus 1 divided by 2 multiplied by n plus 1 multiplied by n plus 2. This is of the type 1 by 4 minus 1 by m. Hence, m is equal to 2 multiplied by n plus 1 multiplied by n plus 2. And that is the answer. Thank you.